Welcome everyone, welcome to the 8086 architecture. As I have promised, I am updating this course and we are extending our knowledge too. So we are going to extensively study the 8086 architecture in this lecture of the microprocessor section. So this is the continuation of the microprocessor and we are going to see that what is 8086 architecture. As we have already discussed in the very brief manner about the architecture and the pin diagram, so 8086 is basically divided into two main segments, which is BIU and EU. BIU is bus interface unit, as you can see, and EU is execution unit. These are the two things that we need to understand if we want to learn 8086 architecture. But it's wonderful processor, so let's begin. So as you can see, I have already made a diagram so that you will not mess up when I will make it up. I used possibly all the different colors so that I can keep it as neat as possible, because when you draw it, yes, it's a little bit messy sometimes, especially on the pen tab when you do that. Okay, so let's begin with this one. As you can see, there are two main segments. The first one here is the BIU that you can see. This is bus interface unit, and the second one here, that is execution unit. So we're having execution unit and the BI unit here, and the memory input output is outside. So this is the line, the boundary that I have drawn from this white line. As you can see here, that is our microprocessor. So this is our microprocessor that we need to study. So we're going to start with one after another, and don't worry if you don't get this diagram at once. We are going to study each and every piece in a detailed manner, and you will enjoy it a lot. Once you understand this diagram, you will feel like you know something very well. So with all that said, let's start the BIU. So what is a BIU? Well, as I said, this is bus interface unit, and what else we mean with it? So BIU takes care of all data and addresses, actually, not just addresses transfer on the buses. Well, buses are the routes where the data can travel. As you might have remembered, we have talked about a little earlier that when you see the pen drive or USB drive, you surely have seen these kind of the lines in that. These are the buses. You can imagine it as the like 3-lane road, 5-lane road, 6-lane road, that way, in which the information or the data travels in the form of the voltage, current, and so on. So this is about it. So here the data travels, and for the EU, like, because we finally need to execute it, sending okay, my writing is a little messed up. So sending, SENDING, addresses, fetching, instructions. So I'm not missing out any point or line, so that you can see everything one after another from memory. So where the information will going to be get fetched? From the memory for sure. Don't worry, it seems like a little boring when I write, but trust me, even if you are reading it, you will get half of the things of the entire story. And we are going to get back to the diagram that I made, and there we will see that what these words actually mean, and then these words will start making the sense, and you can repeat the same line as I'm writing. Just write it 3-4 times or teach it 3-4 times just like me, and you can just write it even when you're talking. And yeah mm, and the memory actually, and the memory, well, I feel like it's a good exercise. You has no direction connection, no direction connections with system buses. Well, if you are deciding to make the notes, you can surely note it down. This will going to help you in answer writing if you decided to answer or decided to re-revise these things by your notes that you are making. So you can add these points in the highlighted manner, because this is something, the essence, the one complete part of the processor. This is possible with the BIU. With the BIU. That's it. We are done now. Well, just for difference sake, let me also tell you that EU and BIU are connected by internal buses. Connected by internal buses. Surely they have to get connected some way, right? Otherwise, how can they are going to communicate? So there are internal buses that connect the BIU and EU. Now let's get back to our diagram. And if you are writing, you can just pause the video here and can write the thing. Okay. So here we have BIU. So what we mean with the BIU? BIU takes care of the data and the address. The data and the address transfer on the buses like EU. These are the buses, as you can see. These are not just a simple diagram or the arrows. These are the buses, the route where the data can travel. This is the first route that we are having. And this one is the second route that we are having here. So these are the two buses that we are having, and rest are the small ones. So these are the routes where the data can actually travel from the ports. You can say these are the ports. The line one, as I told you, these lines are also called as ports. So this is what it means here. And it can read data and transfer the data for the execution and so on. These are the things that actually happen. Okay, let me introduce you to the core parts of it. So this area right here that you can see is actually representing the prefetched queue. These are the prefetched queue. This is 6-byte prefetched queue. So just imagine like 6 people can stand here in the queue till they are not called inside. Just for the sake of the imagination, let's imagine that you are going to a clinic or doctor's clinic. Doctor has to diagnose you, so there are 6 people waiting outside, and they are in their defined row as they came in a queue. As usual, they are in a queue. So 6 people are allowed to be in the queue of the clinic. So this is the concept. And this design here, well, this is not the design here. This is arithmetic logic unit, and here the operations like addition, subtraction, multiplication, division, percentage, and so on, and or not. These kind of operations, whatever the operation that we have learned, are actually done here. This is the ALU, arithmetic logic unit. Don't get confused with this one here from this one here. These both are the same, just the directions are different, just to show that where the input is coming from. That's it, nothing else. Okay, now these are the registers. No, registers are present in the memory. So these are the segment of the registers, and that's it. That's all I want to tell you. Okay, so just doing away and getting introduced with the parts of it. Let's start with the instruction queue. So we have instruction queue. So what is an instruction queue actually? Well, BIU contains the instruction queue actually. That one, 654321, that one is the queue that we are talking about right now. So BIU gets up to 6 bytes of next instruction and stores them. Surely it has to store them, so that's why it is called the prefetching. As you can see in the diagram I have mentioned, it is prefetched. Prefetched means it is about to be go in the line for the execution. So they are standing in the line, they are prefetched, and that's why I have written it stores the next instruction. These are the next instructions in the queue. This is what it actually means. So what are the advantage of doing so? So the key advantage that we got from this thing is speed, increasing the speed. Otherwise, just imagine a scenario that a doctor is inside the clinic. A doctor is sitting inside the clinic waiting for their patients, sitting on their desk, and there are the patients. If every time the patient is in row, so the first one will go, there is one more patient that can come and join the queue, the second one will be go, one more can join the queue now. So this is what actually happens, and there we are having it. So this will increase the speed. Otherwise, what could be the next or the different scenario you might be thinking? Like in the older processor, what we were doing is you are a doctor and you're waiting for your patients sitting on your desk, on your chair, and all that kind of things. Don't mind my drawing, just let's do it. Okay, so first one came and gone to the doctor, and now he will come out. He will go home where he wished to go. He gone to the home, and the next one is still in its way, and then the next one will come, and then the next one will go, and then the third one will going to come. So what actually happening in this case? In this case, actually the speed is decreasing because doctor is free in between 1 to 2 and 2 to 3, 3 to 4, and so on. So in between the cycles of the time, the instruction cycle time is getting wasted. So to use that time very wisely, we queued that data and we have used the 6 byte. Surely these days we are using so many, so as to increase the execution speed very fast. But even the sixth one is not a bad idea, because the instructions are going to be fetched one after another and not all at once. Not all the patients are going inside the clinic for once. So this is the instruction queue, and that's why it is very important to understand the instruction queue. Well, as we have learned the instruction queue in the clinical way, so let me also mention something else. Well, what it is, Om? Well, this is, my dear friend, about the fetching. So, fetching, the next instruction, the next instruction, while the current instruction is executed is called pipelining. Yes, now the concept of pipelining came in the role. So this is called as pipelining. Well, let me also tell you that 8085 do not support the pipelining. 8085 do not support the pipeline. So it is having no pipeline architecture. But surely our 8086 supports the pipeline, and it is having a pipeline structure. So what a pipeline actually do? Pipeline means you can have more than one instruction at a time. As we already know, but just for the memory purpose, this was the 8-bit processor and this is the 16-bit processor. This is the advanced one, this is the lower version of it. It came in 1976. It came after 2 years, 1978. On comparison basis, we will see its comparison just after a few videos. But on a general basis, you can imagine that everything in 8086 is an upgrade of 8085. That's it. In 2 years, what else you can expect? Well, we have added the pipeline. So with the pipeline, there can be increase in the speed. Like if you hire, that's back to the clinic. If you hire someone, your staff, you can say, who manages the queue and look after that the queue will never going to be empty unless all the instructions are actually done, and there is no instruction actually. So unless it doesn't happen, we are having the instruction, it will going to call the next instructions one after another. Okay, so there is a scenario that we wish to talk about here. That scenario is, imagine, well, it's pondering time. So imagine, my dear friend, that what if my instruction requires 12 bytes? So, and already a 4-byte instruction is going on and prefetched. So what will going to happen here? Let's see the scenario, and there we're going to learn something very amazing. So this is 1, 2, 3 and 4 from the first instruction that we are having. Let me change the color so that we can distinguish 5 and 6. So these are the lines that we are having. This is what is actually queued, and here we actually understand that why it is queued and not stacked. Stacking and queuing, right? So what happened when it's queued? First instruction comes in the row, the first getting executed, then the second getting executed, then the third one, and then the fourth one. This is the cyclic manner, first, second, third and fourth. So here we have processed the first one. But if we imagine that it's 12 byte, the next instruction, let's say it's B instruction, it's A instruction, so A is executed already. So B requires 12 bytes. So what happened with the B? We only have 2 bytes of the B. Well, so the 10 remains in our basket for the B. So what actually happens? Well, it will going to get executed. How? Very simple. Let's see. So after the sixth one is executed, let's first execute this one too in our lines. Like fifth is executed and sixth is executed. But when these four were executed, the queue already started moving. Which way it's moved? Well, let me show you with the numbers and you will get the point. 1, 2, 3, 4, 5 and the 6. Now, when the first instruction gone for the execution, the 2 came here, 3 came here, 4 came here, and here it's 5, 6 and the seventh one fetched already. Now when the second one will go out, the queue again changes from the point. Now the new queue will become 3, 4, this will get cancelled out, and now the 5 came here, 6, 7 and the 8 one is fetched, and these all get nullified or get transferred from one point to another, you can say it like that, and so on. So what actually happened? Finally we will able to see that all the instructions are 5, 6, 7, 8, 9, 10. Still the 2 instructions are left. So 2 will going to get execute once the 5 and 6 from these instructions are executing in the execution unit. Well, it always works because they are all queued. Imagine you are making a drawing. Let's imagine this is pondering times ponder with the imagination's thunder. Okay, so let's imagine that you are having a beautiful canvas prepared and you have painted so many beautiful sceneries and drawings and all that kind of things that we make here, and these are our clouds and these are our things and these are our animals, and now we are having so many kind of things and working, well, whatever it is. Okay, so this much drawing is enough to understand. Okay, so what actually happened, you can first draw it and then you can color it one after another. You can color this one first, then this one, then this one, then this one, and then this one, and then maybe the entire sky. That is the whole idea. You are working on the same thing, but you can work on each of the piece separately. Yes, surely you cannot draw or you cannot put in the colors first without drawing this sun. So you will draw the sun first and then you will color. So this is the logic here. When this is the colors that we have to draw, and these are the drawing parts like the heart, the sun, the sky, the birds, if you have noticed my bird here. Okay, so the birds and all that kind of things. So this is what is actually happening, and then when these two get into executed, then the 11th and 12th one will come and they also going to get executed finally, and this will get empty or maybe fetch for new instruction. So this is how our marvelous and incredible bus units prefetched queue works. And why not it is stacked? Because you cannot color first the canvas and then make your drawing. You first have to draw and then only you can color. So first draw and then color. So that's why it is queued. And that always work. Hooray! You have learned something awesomely amazing. Yes. So that's it for this one, and in the next one we are going to see that what actually happened with this ones. So I hope you have enjoyed it. Take care, God bless, and let's keep learning.